All right, so for my aerospace, we're looking at our activity 1.25. All right, this is an example for number 3, so the practice problem that we had from before. So what it's asking us to do is to figure out what our minimum speed is when it lands for this aircraft. So we want to start by marking down what we know. So over here, we're going to start our list of knowns. And we'll have unknown down here. Okay, so we know from reading the question, so we have the same aircraft lands in Hong Kong, so 6 meters elevation. Okay, after a long flight, we may or may not need that one, but we can write it down. So the flight was 5,950. Okay, we used 82,900 liters, which is so much. All right. So it says our average day in July, it was 33.8. That's supposed to be degrees Celsius. Standard pressure, so that's our temperature. Our pressure, 101.3 kilopascals, which is standard for pressure. All right, unknown is our speed. That's our velocity. Okay, it says assume the same 1.5 coefficient of lift. So coefficient of lift is 1.5, and that the jet fuel burned weighs, so the fuel weight is 0.803 kilograms per liter. Okay, so the only thing with this one, somehow we wound up without our weight for our aircraft. So let's pause for one quick second and I will go find that number. All right, finally found it. So I pasted our previous problem in here. So the other piece that we wanted was our weight. So it gave us our weight right here and our wing area right here. Okay, so when we're looking at this, we can put our overall weight. In this one, we're just going to pretend it used that weight specifically. I know that first question had us do some other steps for it. And then our area, 445, we're running out of room here, meters squared. Let's scooch this down. Okay, this should be all the information we need. So, what we know, we have up here. What we don't know is right here. Alright, so our steps, we need to figure out what our velocity is. So if we look at the equations that we have, we are going to wind up using this equation right here, okay, to find velocity, because that's our unknown. Okay, what we can do, and try and color some of these to make sure that they show the same color as here, but I'll take a minute in a few to do that. All right, we have most things colored in now. So we have our temperature over here. We already know it, so we don't need to use our first formula. We have our pressure, which it gives us a standard pressure, which is great. We know our pressure here now. And then it's asking us, when we're trying to find our velocity, we need to see what else we need from here. So it gave us CL, so we have that from our question over here. Our lift, we don't know yet. If you notice, we have nothing up here. That's pink for lift. Okay, our A, our wing area we have. Our rho, we don't have yet, so we need to use this equation. And our velocity is what we're looking for. Okay, so there's two things. There's two more unknowns. Would be rho and lift. Okay, so these are what we have to go find first, so that then we can actually go and find that velocity. Okay, so first let's go with our rho. So if we're using rho, we have our equation right up here. We'll do rho is equal to our pressure, our 101.3. So this is our blue value. Okay. Underneath it, we have a constant, so these don't change at all based on any of our questions. Okay, we technically have our units, joules, kilograms, Kelvin. Okay, times our temperature. They gave us our temperature in the question. Okay, that's going to be our green, since that's the same one as before. Okay, and then we add another constant, 273.1, which does not change. Okay, what we would do is we would then plug this into our calculator. So let's actually show that if you'd like to see. See if I can actually do this all at the same time up here. All right. So what we can do is we plug this into our calculator, if it will let me do this. There we go. All right, so we have our denominator. I'm going to do 33.8 plus 273.1. Since that's in our parentheses first, we're going to do our order of operations. We multiply that by 0.2869. Okay, that gives us 88.05, let's say. Okay, we'll see if our memory actually works today. 88.05. Okay, so we have 101.3 divided by 80.05. That equals 1.15, let's say. This equals 1.15. Okay, so this is our orange value here, our rho. So we just found that unknown. All right, our next unknown is our lift. So for our lift, we have to figure out the main weight of our plane at the time of landing is what it's asking you for. So when we're looking for our lift, we know that we had an overall weight of this, our fuel weight was this, and we used a certain number of liters. Okay, so what we're going to do, let's see if this will let me do this. We're going to bring this down here for ease of use. There we go. And our 82,000 liters, 900 liters. All right, so for lift, we have to be able to use these three together to find how much the plane weighed at that point. Okay, so we have original weight, so we know it started at this value right here. Okay, this is original weight. We have to subtract how much the fuel weighed in total. That should give us the weight we need. Okay, that's what we're looking for. So our fuel weight, we know we used 82,000, so 82,900 liters. We want to know how much that actually weighed total. So each one, it says that each 1 liter, this is over liters, this is an L for liter, so each liter is 0.803 kilograms. So that's from here, that's from here. So if we calculate this value, this will tell us how much all of that weighed. So we have 82,900 times 0.803, so 66,568.7. 568.7. Okay, from here we need to take these, subtract this value here, which equals, we'll do negative plus 347,500 280,931. Okay, about. We need to do weight equals mass times gravity. Gravity's a constant, 9.81. So we take 280,931, it's our mass. Okay, times 9.81. This should give us L.